So we have our lights problem here that we were working on. This thing is pretty sweet. Quick recap. We got, well, hold on. Do we have, is this working? It's not working. We have an error. What is the error? Unexpected. Oh. What happened? Power bill is not defined. Oh, I changed this already. Oh, get total bill. Bonk. Hey, okay. Sorry, I already had changed something before I started this video. So the problem, to recap real quick, is that we're plugging in strands of lights one at a time. The first one gets connected to the wall. We had said the wall is going to be represented by the 0 on live connections here. And we're trying to calculate the total power used. So 3 can't be pulling power before 2 happens, and 2 before 1, and so on. So in this case, the answer we're looking for is 35. We're getting a 9. So something is gone awry here. And there are a couple optimizations that I think we talked about and were coming to mind as we were coming through. One thing so there's a few just like red flags, not red flags, but like code smells that I would mention here from the outset. So we have these global state kind of things sitting out here, but we're also passing in, I think our instinct to pass variables in versus using global state is a good one, but we actually didn't have this function get total bill. We just were directly reducing on like the main scope. So I went ahead and added this function. What I'd like to do is actually hold on, let me throw this like this, and what I like to do is pull these global variables in here because we're already passing them, and that way they're scoped to get total bill, right? And that should still work. And that way we can duplicate this, and we can say, well, that was Command Shift D, by the way, duplicates in CodePen, duplicates a line. And I could say 1, and then cool, and that works too. So that gives us flexibility, that gets rid of that little code smell. Another thing, I don't like let. While is kind of a code smell, but kind of works really nicely in a lot of situations. Another thing I think we talked about is that we could just add new connection to dead connections, because we're basically doing the same check here for the new connection as we're doing for every dead connection. So why not just add it on, and then you can reuse the same code. So let's do that. What we have to be careful of now that we're passing these in is that we are using mutative functions. If we made this something like live did and like total, and we were always returning this object from our make connection, returning each value, then we wouldn't have to mutate. But let's go with mutating for now and see what that looks like. So if we want to mutate dead connections and tack on new connections, we need to use mutative array methods, which are push and pop, shift and unshift. And I always get these things confused, but I think we want to just push it on. That makes sense to me. And then we don't need to do this or this or this, because here we're already pushing it on no matter what. And so that's still kind of nice. So now, we went to 25 at one point, and now we're at 39 as an answer. So we went too far the other direction. So something that I just said is that we're going to have to use these array methods, and we can't assign this, because when you assign something an object, so an array is an object, so dead connection is an object. When you assign it in a method, when you're passing it, it actually does not change the reference outside of it. So objects are like technically like everything in JavaScript is passed by value, even though objects act like passed by reference, because if you modify or if you use mutative methods or you modify anything on the object, the original will change, but the original reference never actually changes. So what you're passing into a function here when you're passing an object is a copy of the reference. If that makes sense. So if you change the reference here, you're not changing the reference here because it's a copy of the reference. But the reference will reference the exact same memory positions of everything inside of the object. So if you assign or mutate anything in the object, this one will also reflect those changes. It's weird and complicated. But the point is, I think that we don't want to change this reference here because this would just change the copy and not affect this at all. And so effectively we're just losing what we did here. Even though, well, we're not losing the initial one because the initial one actually is using splice. Splice is mutative. It'll mutate dead connections, and we got that. But every subsequent while loop, we're actually just mutating the... actually, that should also mutate... Oh, it's mutating a new reference, but that is still referencing the same things internally. I'm not sure about this. I'm gonna have to look it up more. Either way, whenever you're using a mutative function on an array, you typically don't assign it because it's redundant. And if we remove that, now we're up to 44, which is interesting. Yeah, I'm not sure actually why that changed. I'm gonna have to look into that more later. But I think the reason we're so high is because we have this 0 here that we're counting every time. So we can just tack that off of each one, and then we're there, 35. Yeah, cool. Because we were counting the wall, but the wall doesn't drop power, so we don't need to count that. One other thing is, I was thinking we could do splice is not commonly used. It's kind of strange thing to do. Normally you can do that thing where you like have a new array and you do ... up to some index, and then ... after index, and then that's like the new fancy way to splice. I just don't like splice in general. I think what we could do here is sort dead connections, because we already know that live connections is sorted. And remember, when you're sorting numbers in JavaScript, you do have to provide the compare function, because it by default coerces to a string, and like for example 10 is less than 2 when coerced to a string, so it only actually works the way you'd expect when you provide this function. And this function, this compare function you provide, returns positive, negative, or 0, and that tells it whether to switch one way, the other way, or leave it. And so that's why a minus b works, because that will end up being a positive number, negative number, or 0 when it's an integer. This doesn't work for like objects or anything else. So if we sort dead connections, then we have the smallest number dead in the first position of dead connections, and we have the largest number that's live as the last position of live connections. So basically all we want to do is we want to check if the next dead connection is the one that we need, and then we can just pop that thing off, push it onto live connections, you know, basically shift from the beginning of dead connections onto the end of live connections until it's not the next one we need. So we could just do push on, we know it's the right one, so we can just shift it off. Again, I always have to look these up, but shift is the one that pulls off the beginning of the array, and it returns the element that was shifted off. When you're adding onto an array with unshift or push, it does not return the element or the array, it returns the length. so don't don't get that messed up. So then we don't need this because we're already shifting it, the one that we didn't want off. And this, because we're kind of assuming that everything's going to be in order and incremental, we can actually just plus that. So we're constantly looking for the next one as the first one of dead connections until it's there. And it looks like that works. So now we can like gut check this, see if this works. This should be 1 plus 2 plus 3, so 6, yep. If we do 3, 2, 1, that should be 3, yep. So it looks like this works. If you have any other ideas or recommendations or things we could do in here, or optimizations, or make this more readable, let me know. And have a good one.